Okay, so now we need to put together all the pieces to graph this rational function. The first thing we need to do is make sure it's in factored form. So the top of this one is already as low as it's going to get, it's linear, but the bottom can be factored. So we're going to go ahead and factor that. All right, now we're going to just find all the pieces that we need. So looking at the degree on top is 1, the degree on bottom is 2. So bigger on bottom, Bobo. So that means that y equals 0 in this case, which means I have a horizontal asymptote of 0, which means that I don't have a slant asymptote. All right, so now going over to the other side of this where it says x-intercept. So this is the first time we've actually used the top of our fraction. X minus 6 is going to be set equal to 0. Solve that, and that will give you your x-intercepts. In this case, I just have 1. It's at x equals 6. I'm going to go ahead and go over here and graph that. I know it's going to cross at x equals 6. Now that's interesting because I know I have a horizontal asymptote at the x-axis, but for some reason this graph is actually going to cut through that horizontal asymptote. Don't let that bother you. These rationals have different behaviors because they're different discontinuities. Now in this case I don't have a removable discontinuity or a hole because I don't have any matching factors. So both of the bottom pieces are vertical asymptotes, x equals -2 and x equals 4. So let's go ahead and draw in our asymptotes. So if you'll sketch those in, because the point here is to graph this, so we need to know exactly where our asymptotes are. So I've got an asymptote at -2, and I have another one at 4. All right, so now we need to identify what our critical values are. Critical values are anywhere on your graph that you have a discontinuity. It's the x values that are causing the discontinuities that are your critical values. So this number line down here, we're going to put all of our critical values on there. So I have critical values on this particular graph at -2 and 4. Those are both vertical asymptotes. I also have a critical value at x equals 6. It's critical because that is an x-intercept. That's a 0. That's a solution to this problem. So that's critical. All right, so for the purposes of figuring out what this graph is going to look like, I'm going to draw a line down at all of my critical values. So there's -2, there's 4, and there's 6. Now, this is just to help me determine whether the graph is going to be above or below the x-axis in certain points. So I have my 2 vertical asymptotes and I have my 0. And over here on the left-hand side, you're going to list the factors. What you're doing is figuring out if the entire function turns out to be positive or negative. But it's easier to break it down by factors than it is to plug values into the entire function because the function is a big nasty fraction. So we're just going to list out the factors. So now, looking from the vertical asymptote to the left, so all these numbers are negative. If I plug any one of these numbers in to x minus 6, the whole thing would come out to be negative. Same thing for x minus 4. The whole thing would be negative. Same thing for x plus 2. Those would be negative. If I plugged in, let's use 0, because 0 is in between these 2 vertical asymptotes. 0 minus 6 is negative. 0 minus 4 is negative. 0 plus 2, that comes out to be a positive value. So I'm going to put positive. All right, so between 4 and 6, let's use 5. 5 minus 6 is negative. 5 minus 4, positive. 5 plus 2, positive. I don't really care what the value is. I just care whether or not it comes out positive or negative. And then to the right of 6, if we were to plug 7 in, this one would come out to be positive, positive. And if we plug 7 in this one, it would also be positive. All right, so now, if I look down and see what does that cause my entire function to do? A negative times a negative times a negative is a negative. That means this portion of the graph is below the x-axis, where the negative numbers are. A negative times a negative is positive times a positive is positive. So this portion of the graph is above the x-axis. Now between the vertical asymptote and the x-intercept, negative, positive, positive, that's negative. That means right here it drops below the x-axis. And then positive, 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 above the x-axis. So we're just trying to figure out where this graph lies. So now let's go up and let's graph each one of these. Now it just has to be a sketch, it doesn't have to be perfect. But I know that to the left of my vertical asymptote at -2, I've got to be below the x-axis. So remember what a rational looks like. And going from the -2 below the x-axis is going to look something sort of like that. It's not perfect, but it's going to look something like that. Now between my vertical asymptotes, it has to be above the x-axis. Well, it's got to be between, the whole thing has to be above the x-axis, which means it has to turn like this because it can't cross those vertical asymptotes. Now this is the one that has to cross the x-intercept. So it's going to cross over my horizontal asymptote. It has to cross at that point because that's an x-intercept. So it looks something like that.